Ask. More questions, the better. I feel like, not really picking on you guys, but my Math 9 class is great with questions. Maybe first year high school it's a little bit harder for you guys, senior high, but hopefully we can get out of that soon. Okay, so this is Unit 5, Lesson 1. So we're starting System of Linear Equations by graphing. So this one's the graphing portion. So this one's a little bit more straightforward in terms of it's essentially going to be where they cross as the answer, okay, because that's a spot they share. Okay, we'll talk about what that means, but just in general. Okay, so exploration, the Smith family and the Harper family are going to book a book fair raising money for charity. Mr. Smith pays entry fees of $11 for 3 adults and 1 child. Ms. Harper pays entry fees $12 for 2 adults and 3 children. We can determine the cost of the adult ticket and the cost of a child ticket by forming 2 linear equations and graphing them. In examples like this, being familiar with general form is helpful because we're comparing 2 things, x and y. Now, in general, there's not necessarily an independent or dependent variable because when we have y equals mx plus b, x determines the y, right? Do you guys understand what I'm saying? So when we have y equals mx plus b, let me explain what I'm saying here. So slope-intercept form, numbers that I put in here give me something here, right? Inputs put in outputs. But when I'm doing ax plus by plus c, they're just 2 separate variables that are like they don't depend on each other. And so general form helps us in examples like this because adult and child, they don't depend on each other. They're just a number. We're comparing 2 quantities. Okay, so general form is best used when you're not comparing, or excuse me, yeah, when you don't have a comparison or an independent versus dependent variable. Okay, so that's why here, it doesn't really matter what our x and our y is. We could flip it. So if you ever are doing some test, and let's say on my key I do kids down here and you do kids here, you'll still be fine as long as your points are just flipped of mine. Okay, so just keeping that idea. I know that we understand independent variables and whatnot, but I'm just kind of telling you this is a time. General form is great for when you don't have that. Okay, sorry. All right, so then let x be the entry fee for adult ticket, y be the entry fee for a child ticket. The information about the Smith family can be modeled by this equation. So if you look at the Smith family, they said that Mr. Smith paid $11 for 3 adults and 1 child. 3 adults, 3x, 1 y, 1 child is $11. Everybody comfortable with that setup? Okay, and then Miss Harper paid $12 for 2 adults and 3 children. 2x and 3y equals 12. Okay, so that's the setup. So it says draw the graphs of the equation 3x plus y equals 11 and 2x plus y equals 12 on the grid without using technology. So what we're going to do is, it is hard to graph these, but we can still solve for y and still graph it like I said. Even though it's not independent versus dependent, we're going to solve for y to figure out the what? What we just did over there on the warm-up. The y-intercept and the slope. Okay? This is not friendly to graph. Do you guys understand that? So we're going to make it friendly. So let's do this one here. 3x. Oh, that's going to be an easy one. That's nice. Why am I saying this is easy? Because all they do is minus 3x. I have y by itself. That would be the Smith family's equation in terms of being able to do slope-intercept. We good? So theirs is going to be plus 11 down 3 over 1. Okay. So their line is roughly going to be that. Why did I stop? Why do I not have arrows here? We can't go into negative because that would represent negative people, right? And then I also can't what? I can't go negative the other way either. So we can't do negative x's or negative y's because we can't have negative people. Okay, so that's why I stopped on these graphs. Okay, next one. So we're doing the Harper family. 2x plus 3y equals 12. So we're going to minus the 2x. 3y equals negative 2x plus 12. Divide by 3. I'll stop here in a second so you guys can look at it. Sorry. Negative 2/3 x plus 4. So if we graph this one, I'll switch my color here. If it'll let me. Sometimes it lets me. Okay, so I start at plus 4. I'm down 2/3. There's that one. So where's the solution? It's right here, where they crossed. What that solution tells us is how much it costs per kid, per adult. Okay, so look. For your x, we're at where? We're at 3. So that means for adults, is $3. Where are we at for the y? 2. Child is $2. So we just figured out by using a system of equations. Questions on that? Okay, the reason where they cross as a solution, because they paid the same price, but we don't know the price per person they paid. We just know the total. So we took that and we converted it to graphs, and where they cross tells us the price they're paying. Okay, so that's how that works. If you're wondering why does that work that way, well, because watch. I'll show you actually. This will kind of check our work. If I put a $3 here and a $2 here for y, what is 2 times 3? 6. What is 3 times 2? What's 6 plus 6? That's not a coincidence. Okay. Then if we go over here, what is 3 times 3? Plus 2. It's not a coincidence. Okay. So we found the solution of how much they cost. Okay. Perfect. Okay. Today's one of the first lessons, so it's going to be a little bit slower, okay, and redundant. So if you have questions, ask, but it's going to be not longer, but just not a short lesson today. The graphs of equations intersect at a point, state the coordinates of the point. So we can already skip this here. I'll write it here so you guys can see it. Our point was 3, 2. That's where they crossed. Okay, explain what that means. We did this already. Adult is $3. Child is $2. That's what that meant. Okay, system of equations. So in the exploration on the previous page, we worked with an equation 3x plus y equals 11. There are many values for x and y which satisfy that equation. Yet we worked the other equation, but however, they only share one spot. Okay, both these equations, there's only one solution, which was 3, 2. The system of equations considered at the same time are called a system of equations. So when you're talking about those two examples of them paying that much per person, per child, per adult, they create a linear equation in terms of cost. Where they intersect is where they're going to specifically tell us how much each adult and child is. Okay. Our solutions, what we just talked about, we just tested this. The solution satisfies both equations. So whatever our answer is, it has to work for both of them, not just one. That wouldn't make sense. Okay. All right, let's look at this one. A system of equations has been represented on the grid. The system has an integral solution. So integral means what? You guys should know this from general form definition. What does integral mean? You should know this from number. Integer, what does integer mean? When they're saying that, what are they telling you? Opposite. They're saying it's a whole positive negative number. I thought you said it's a fraction. Oh, sorry, I just heard the last part. You were correct, Caleb. Yeah, so no decimal or fraction, positive, negative. Okay, perfect. So state the solution. So right here, we just got to look for the what? This picture here, what are we looking for? Right here, where they cross. That's your answer. They told you it's an integral solution, so if you think, oh, it's a little bit left or right, no, they're saying it's right there on 2, negative 1. 2, negative 1. Okay, rise in ordered pair. Ordered pair is a point, right? 2, negative 1. How's it going? What can I help you with? Okay, consider a system of equations. 2x plus y equals 2. X minus 3y equals 15. Graph the system of equations without using technology. So we're going to show the calculator part last. I think it's actually the next lesson. So again, go ahead and try this one. First thing you got to do is solve for y, okay? Solve for y and get that graph real quick. I'm going to give you some time here. Okay, so the first one is nice because all it do is minus the 2x over. So it's going to be y equals negative 2x plus 2. Okay, so remember, y-intercept is 2, so that's where I start, right there at 2. Negative 2, so down 2 over 1. Let's get the highlighter. It's a little easier to hit these dots here. Okay. So you can kind of see this line here. Looks roughly like that. Using a ruler and stuff is really helpful here. Mine has a bend in it, so if it crosses somewhere in my bend, it might be a little bit off. Okay, so just keep that in mind. Okay, so here I'm going to minus x. Negative 3y equals negative x plus 15. Divide by negative 3. Divide by negative 3. Y is 1/3. That's what's right here. It's a 1x over 3. Minus 5. So we do this one. Minus 5 is where I start, so I go to the y-axis, minus 5. 1/3, up 1 over 3, so it intersects right there. 3 negative 4, you said? Yeah. Okay, and as Logan just said right there is 3 negative 4 is your solution. So you state that right here. Okay. Algebraically verify, so that means to plug it back in like we did before. So we're going to plug this x and y into both equations, and remember that should come out equal. So watch. 2 times 3 minus 4 equals 2. 2 times 3 is 6. 6 minus 4 is 2. The first one's check. So what I did was I took this point, I put it into this one right here. Okay, and so it was equal to. All right, so then now the next one, I'm going to try into our other one. So 3 minus 3 times a negative 4 equals 15. What's a negative 3 times a negative 4? Positive 12. Tricked you. Okay, 3 plus 12, 15 equals 15. So that one works. Okay, so we just verified that that is the solution. Questions or concerns with that one? Okay. Sorry, we started. Okay, all right. So solving system equations. So this is using your graphing calculator. So we are doing that today. Okay, it's pretty simple. I'll kind of walk you through the steps and we'll do a couple, okay? We're going to use the intersect feature because we're finding out where they intersect. Remember when we did intersect for the, what did we do the intersect for? We did the intersect for the, oh, we did what? Yeah, when we had two y's, remember? It's essentially the same thing, okay? So write the equation in terms of y. So we have to get the y by itself because your calculator can't graph unless it's y by itself, okay? Access the y equals editor, so that's just hitting the y equals. Enter your equation 1, enter your equation 2, hit graph. So you're going to have two lines crossing themselves, okay? Then second trace intersect. And when it says first curve, second curve, all you have to do is making sure that it jumps to the other line. It doesn't matter which one it's on. It'll blink on one of your lines, and you hit enter. It should jump to the other. Then with this guess, go close to where they cross. That's all you have to do for the steps, okay? And so that's what this is telling you, first curve, second curve. And then enter on the guess, all right? So let's do this one with our calculator. So what we're going to do first is we have to get y by itself. And this is the one we did. This is from the very first question we did. So we already know what the answer is going to be, but we're going to make sure we get that with the calculator, okay? So first one, y equals negative 3x plus 11. So I move the minus 3x over. You'll put that in your y1. Second one, minus 2x. Divide 3. Your second one in the y2 is going to be y equals negative 2/3 x plus 4. On the negative 2/3, put brackets, and make sure you use the negative sign, not the minus sign. It'll mess up if you do. Go ahead and graph that. The negative 10, 10 window should be fine, just the standard window. Okay, and I want you to try to do the intersection. Okay, I'll pause the video, give you a chance to try that with your calculator. Let me know if you need help. Okay, when you guys did that, the window that's best is just the standard one, so you could use negative 10, 10 with the scale of 1. Your y could have been the same thing. Okay, like I told you, it's very helpful because some of you guys, if your window's out of whack, you have a tough time getting back to normal, go into the hit zoom and select zoom standard. That goes back to the negative 10 setting, which is the basic one. Solve system equations, you guys did that. You should have got the 0.32 again, which was $3 for adults, $2 for children. It was the problem from earlier. Okay. All right, so we're just finishing up here. Last page. Okay. If a decimal value appears for x, so this is the situation where we don't want to round. Okay. So if you get like a 6.6 repeating, remember, this is how you can do this. You can go hit your, so exit the graphing screen by pressing clear twice. So where you're at, press X and hit enter. Okay. Once you hit enter, import the X coordinate, and you'll have display the max value. So here, let me show you what it's talking about. So everybody in their calculator right now, hit this button. You should be back. We're not in the graph anymore. Okay, and then hit enter, and then you should import the X coordinate. So hit like a negative, oh, you have 3? Yeah, so you guys all should have 3. Did everybody get 3? Hit X and hit enter. 2.97. Okay, good. So, good, yep. Okay, yep, 2.97. So a lot of you guys are going to be really close. The reason some of you guys might be 2.97, you might have moved off there just like one click. Okay. Yours is 10, yep, so you might have moved off there. So, okay, listen. When you, just let me tell you what this is doing and you'll understand, okay? What this is doing is when your trace, when your blinking guy is on a coordinate, okay, it has an x value, right? Because that coordinate will be x something, y something. When you hit x, it's going to say, this thing's saying, where was their trace last? And it'll enter that. So like Aiden has 10, so I'm going to guess that he may have moved his around a bit and it was on 10 for some reason. So that's why it kicked out 10. But what this is telling you is if, for example, if we do a solution, let's just say we do a solution where we get x equals 2.6 repeating. I'm just making this up. So if I do x enter, it'll give me that number. But next thing I'll do is I'll hit math fraction, and it'll change that to a fraction which is exact. I won't have to round. So that's what this does for you. Okay? So what I'm telling you is they're teaching you that if you get something that's not a nice smooth number for an answer and you want it in fraction form, because your calculator on the graphing method always uses decimals. Okay? It's helping you change the fraction, and this is what you do. You hit math, fraction, enter, and it'll change. So this one would be 2 2/3. So this one would change to 8/3 if I did math fraction, which 8/3 is more acceptable because it's an exact form. What does exact form mean? No rounding, right? Exact, exactly. Exactly, exact. Okay? Same thing for the y, but you hit alpha 1 enter to import the y coordinate. So that's going to actually hit the alpha, the y letter, and you should get, most of you should get 2, right? Okay. Yours is probably going to be different because you had 10, right?
No,
so you're.
I changed it to 2.
Oh, you did?
I mean to 3.
So alpha 1, they said, is enter. Yeah, there you go. Everybody good with that? Did you hit alpha 1?
2.
Did you hit 2? Okay. Should be good. Everybody's okay with that? Okay, let's try this one here. This is going to be a decimal, so this is where we're going to be able to fix it. Okay, solving using system equation using graph calculator. Real quick, let me look. I'm going to pause the video. I'm going to look and see what I'm assuming B is Y, but I'm going to double check. Okay, so picture B is Y. Okay, so all we're going to do here is we're going to get Y by itself again. So I'm going to get 7B equals negative 6A plus 5. Divide 7, divide 7. B equals negative 6 over 7A plus 5/7. So we're going to put that into our Y1. Make sure you use brackets around your fractions. That's a 5. Sorry, it's 5/7 here. Let's erase that. Try again. Next one, we just simply have to divide by 14. So Y2 3 over 14a. So practice what I just told you. Find where they cross, and then give me the exact values. Okay, give me the exact values. I'll pause the video so you can try that. So a lot of you guys got your exact values. Your x was 2/3, and your y was 1/7. Great work. To algebraically verify, we can just plug those into the 2. So remember, x is A, y is B. Okay, so if we plug this in, we'll algebraically verify. 6 times 2/3 plus 7 times 1/7 equals 5. 6 times 2/3 is 12/3. 12/3 is 4. 7 times 1/7 is 1. 4 plus 1 is 5, so that's verified. The second one, I plug into the second guy. 3 times 2/3 equals 14 times 1/7. 3 times 2/3 is 6/3, which is 2. 14 times 1/7 is 14 over 7, which is 2. We just verified algebraically. Okay, that's it for lesson 1, unit 5.